Welcome to GK TechVerse. Let's dive in.
This video continues our Core Java interview series for beginners. Today we will be diving into the fundamental concepts of object-oriented programming. So we will cover all these questions, okay? Around 20 plus questions we will cover. I will make it simple by splitting into multiple parts. The first part we will cover these highlighted questions. So most developers can write Java code but struggle to explain OOPs clearly in interviews. In this video, we will build your OOPs foundation step by step. What is object-oriented programming? We can call short form OOPs. Object-oriented programming is a programming model based on the concept of objects. In OOP, we organize code using classes and objects instead of functions and logic alone. If you see the detailed explanation here, earlier programming languages focused on mainly functions and procedures, but OOP focus on objects that represent real world entities. For example, instead of writing separate functions for a student, we create a student class that contains data and behavior. If you see this example here, we create a class student which will hold the data and behavior. Why object-oriented programming? What problem does it solve? So using object-oriented programming, any language, if you take Java, .NET, Python or TypeScript, we commonly use object-oriented program because it's a code reusability, better security, easy maintenance and scaling your application. It is based on four main principles. We call it as four pillars. Those are encapsulation, abstraction, inheritance, polymorphism. We'll see more details in the further questions. What is a class and what is an object? A class is a template used to create an object. An object is an instance of class that contains actual data and behavior. In simple terms, class defines structure. Let's example, it's a house blueprint. Object represents real implementation. Example here, using that house blueprint, we can actually build real houses using that blueprint. You can build many houses from same blueprint. A class is a user-defined data type, contains variables, contains methods, does not occupy memory until object is created. Example here, student is a blueprint. Let's say, so we have created a class student and we have defined variables and method. What is an object? An object is a real world entity created from class using new keyword. Now it will occupy memory in heap. As we know, whenever you create any object using new keyword, this will occupy now memory in heap. Can access class members. Here we have created a student object using student class. S1 is an object of student class and we are able to access class members like name, age and method, right? And we'll see the memory flow here. S1 variable will store in stack memory and which is reference to student object which is in heap memory. What are the four pillars of OOPS? We already discussed object-oriented programming based on four principles. These four pillars are encapsulation, abstraction, inheritance, polymorphism. Using these four principles, which help us building modular, reusable, secure, and maintainable application. Code reusability. Instead of writing the same logic 10 times, you write it once in a parent class and inherit it. Better security. By using encapsulation, you prevent external code from accidentally corrupting sensitive data. We'll discuss more. So here the benefits are like easy maintenance, like because of code is modular, broken into multiple objects, you can fix a bug in the payment object without touching the login object. Scaling issues. It makes easy to manage massive projects with millions of lines of code by breaking them into small manageable pieces. In short definition of each principle, encapsulation is protecting your data, abstraction adding your implementation, inheritance reuse code, polymorphism many forms. In further question, we will get more details of each principle. Explain encapsulation with example. Encapsulation is the process of wrapping data and methods together into a single unit called class and restricting direct access to the data. In Java, encapsulation is achieved by declaring variables as private, providing public getter and setter methods. It helps in data hiding and security. We'll see in the example. If we allow direct access to variables, anyone can modify data, right? In this example, we'll see here, I have created a student class and we have given the field called age as a public so that anyone can access and anyone can set age as negative numbers. So then there will be an issue, right? Instead of that, what we will do, we'll make it as a private. All the fields will make it as a private so that the data will be hide. So we are protecting our data and using the public getter and setter, you will set the actual value and we can put the validation here. Okay, if age greater than 0, so you are always validating that input age, right? So by this way we can restrict the data, right? So here if you see student, we have created an object and we are setting age using setter. By providing this value, this setter will check if age is valid, will take, right? So encapsulation is very important to protect your data. It allows validations, improves security, makes code maintainable, and supports abstraction. Explain abstraction with example. Abstraction is the process of hiding internal implementation details and showing only essential features to the user. It focuses on what an object does, not how it does it. In simple terms, client will see only the function, method. The behind implementation will be in the behind. In Java, abstraction is achieved using abstract classes and interfaces. For example, when we define an abstract method in a class, we hide the implementation details and allow subclasses to provide their own implementation. This helps reduce complexity and improve maintainability. We'll see with the example here. So what is an abstract class? So here the abstraction is possible using abstract classes and interfaces, right? Using abstract class, let's say you declared class as abstract. It means this class can have abstract method and non-abstract methods. Okay, what is abstract method? Abstract method is nothing but the method will not have any implementation, will not have any body. This will only say, okay, the method name. Okay, then where is the implementation? The implementation will be from the child class. So when child class is extending parent class, so this will call inheritance. We'll see in the next topic. So here the car class extending vehicle class. Vehicle is the parent class and car is inheriting the parent class, and this child class should provide the implementation of that abstract method. So now here's, if you see, this stat method is a abstract method and the implementation will be there in the child class, right? So here I have created a object, okay, using the parent class. I have created a child class car object. Now if you see here, I am able to see only the function name, like I am calling only start. Okay, it doesn't know what is the implementation. User will see only the function. So here I am calling start stop. The actual implementation will be available here, right? This is called abstraction, right? So abstraction can be possible using abstract classes and interfaces. Using abstract classes, we have seen like this one. So you have to declare a class using abstract, and you can provide abstract method or non-abstract method. Abstract method implementation will be there in the child class. Okay, an abstract class also have the non-abstract methods. Okay, so here abstraction can be possible using interfaces also, like we can create a interface. Okay, so using interfaces, interface will have only abstract methods. Okay, so here we have created an animal as an interface, and we created an abstract method. Okay, in interface every method will be a abstract method by default. It doesn't have any implementation. So now class dog implements here animal. So this child class must implement the abstract method. So sound, here we are implemented. Now we have created a dog object using interface. Okay, and we are able to see that function sound. Okay, we are not know about the implementation, we are just making call to the function name. The actual implementation is in the child class, and we are hiding the implementation by default. We are only calling the function name, we don't know what is the implementation, right? So user only sees the method declaration, implementation is hidden. This is called abstraction. So important interview points you need to remember: abstraction achieved using abstract classes and interfaces. Cannot create object of abstract class. Okay, using abstract class you can't create an object, right? We see here we are creating a child class object using abstract class, but we cannot create a vehicle object here. Okay, abstract methods have no body. Interface provides 100% abstraction. Encapsulation versus abstraction. So we already discussed encapsulation and abstraction. Now we'll see what is the difference here. Encapsulation is about hiding data and restricting direct access to it using private variables and getters and setters. Abstraction is about hiding internal implementation details and showing only essential functionality using abstract classes or interfaces. We have seen that no abstract classes and interfaces. In simple terms, encapsulation hides data, means protecting data. Abstraction hides actual implementation. So encapsulation wraps data and methods together, restrict direct access to variables, achieved using private variables, focuses on data security, right? So here we have seen that no student class we have created and all the fields we declared as a private, and using public getter and setter we are setting the values using validations, right? And abstraction hides internal working logic, shows only essential methods achieved using abstract class or interface, focus on reducing complexity. So this is the table structure. So the purpose we'll see, encapsulation is only for hiding data, providing the security. Abstraction hides the implementation achieved using private variables. Abstraction using abstract class or interface. Focus, security, complexity reduction, and example, using getter and setter we can achieve abstraction using abstract method.
Thanks for watching GK TechVerse. Subscribe, stay consistent, and keep upgrading your skills. See you in the next video.